Good evening, dear aspirants. I welcome you all to the day 2 of the discussion on behalf of ACE Engineering Academy. Okay, I faculty Muhammad Waheed at ACE Engineering Academy will be discussing with you today velocity analysis of the mechanism. Okay, so the methods available for solving velocity analysis or carrying the kinematic analysis. Methods for kinematic analysis. First is that, guys, we have I-center method or instantaneous center method. Okay. Next is relative velocity method or the graphical method. Next is analytical method, or which we will be basically making use of vector algebra. Okay. And one more thing to inform you guys, that in the examination, the mechanism, especially will be dealing, when we are dealing with kinematic analysis, the mechanism will be given in such a way that we will be taking 1 or 2 trigonometric ratios and obtaining the rest of the values required within the mechanism. So we'll be dealing with the special cases. Okay. So first is that we'll start with I-center method, guys. Now in I-centers, guys, we have to make use of Arnholz-Kennedy's theorem, and there is one more formula to calculate the number of I-centers for the given number of links. Okay, so first let us write number of I-centers if there are n number of links, I-centers for n links is given by NC2. Okay, so we'll be considering 4-bar mechanism, guys. In case of 4-bar mechanism, it will be 4C2, which is equal to 6. There will be 6 I-centers, guys. Now let us draw the 4-bar mechanism. Okay, this will be link 1, link 2, link 3, link 4. Right, now number of I-centers. So wherever there is a revolute joint, there we can mark the I-center. In this mechanism, we have 4 revolute joints. At those 4 revolute joints, we can mark the I-center. So this will be I1, 2. This will be a revolute joint between 2 and 3. So we will mark this as I2, 3. And this will be revolute joint between 3 and 4. We will be marking this as I3, 4. Next is, there will be a revolute joint between 4 and 1. We'll be marking this as I-center, I1, 4. Okay. Now guys, we have located 4 eye centers. Now, the remaining 2 eye centers we have to locate by using Arnhold-Kennedy's theorem. Okay, let me just write the statement for that. Okay, so here is the statement. If the 3 bodies are connected, are so connected that they transmit relative motion So these 3 bodies, they can be in physical contact or may not be in physical contact, but they can be part of one mechanism, guys. Okay, so 3 bodies are connected so that they transmit relative motion, then their eye centers will be collinear. Very, very important statement, guys. Then their eye centers will be collinear. Now, guys, the remaining eye centers we have to locate by using this theorem. Okay, we have to locate by using this theorem. Now, guys, for that, first is we are required to draw the Kennedy's circle. Okay, we are required to draw the Kennedy's circle. So this will be the circle. Let us mark the links. There are 4 links. 1, 2, 3 and 4. Okay. So here we have located I12, 1 to 2, 2 to 3, 3 to 4 and 4 to 1. All these eye centers are located, guys. The missing eye centers are 1, 3. The missing eye center is 1, 3 and another missing eye center is 2, 4, guys. Another missing eye center is 2, 4. Okay, these 2 are the missing eye centers. So for locating 1, 3 and 2, 4, we are required to make use of Kennedy's theorem. So here if we notice 1, 3, if I want to reach the point from starting from 1 to 3, I have to go 1 to 2 and 2 to 3. I can go via point 2 and then I can reach point 3. Okay, so which means that 1, 2 and 2, 3 must be collinear with 1, 3. I am considering the links 1, 2 and 3, guys. For that, it will be 1, 2 and 2, 3 should be collinear with 1, 3. So 1, 3, guys, is going to lie somewhere on this line. I am extending this line. Somewhere on this line it is expected to lie. Okay. This will be the line of I13. Okay. Next is, guys, if I want to reach the point 3, I can start from 1 and again go via point 4 and then reach the point 3. So here I am considering link 1, 3 and 4, guys. Link 1, 3 and 4. 3 is not physically connected with 1. Here if we notice, 3 is not physically connected with 1, but it is connected with 4 and 4 is again connected to 1. Same was the case when we are considering the link 2 and 3, link 1, 2 and 3. Okay. So here we can say I14, that is 1, 4 and 3, 4 must be collinear. Okay. So here I can say that is 1, 2 and 2, 3 must be collinear with 1, 3. Next is 1, 4. Next is 1, 4 and 3, 4 must be collinear with 1, 3. 1, 4 and 3, 4 must be collinear with 1, 3. So I am going to extend the link number 4, or I am going to extend the line joining 1, 4 and 3, 4. So when I extend these two, they will be meeting at this location. We will be calling this as I13. I13. Okay. Now guys, the same way we can make use to locate 2, 4 also. So here, if I want to reach the point 4 starting from 2, I can go via point 1 or via point 3. So here I can say 1, 4 should be 1, 2 and 1, 4. 1, 2 and 1, 4 should be collinear with 1, 2 and 1, 4 should be collinear with 2, 4. Okay. 1, 2 and 1, 4 should be collinear with 2, 4. Similarly, if I want to reach point 4 starting from 2, I can go via 3 also. So here I can write 2, 3 and 3, 4 must be collinear with 2, 4. 2, 3 and 3, 4 must be collinear with 3, 4. Now guys, if we notice here, okay, so if we extend the lines of 1, 4 and 1, 2, 1, 4 and 1, 2, this is the line. 1, 4 and 1, 2, this is the line. Next is 2, 3 and 3, 4. 2, 3 and 3, 4. If we extend this line, it will be this one. This is where I24 is expected to lie. Okay. So now guys, here, now here we can notice that 1, 2. 1, 2 is the permanent center of link number 2. 1, 2 is the permanent center of link number 2. And similarly, 1, 4 is also the permanent center of link 4. Okay. So link 2 is undergoing rotation with respect to I12. The motion of link number 2 is purely rotation. Similarly guys, if you observe link number 4, either this link number 4 may undergo rotation or oscillation, but its center of rotation will be I14. So now it is definite that link 2 and link 4 will be undergoing angular motion guys. Okay. It is angular motion. That angular motion can be oscillatory type or rotatory type. Now guys, here if we notice, after certain time we will see the link 3, the orientation of link 3 after a certain period of time, we will notice that it is getting changed. So when the link 3 orientation is getting changed, I13, the location of I13 will be also getting changed. So here 1, 2, 1, 4 and 1, 3 are the centers of rotation of link 2, link 3 and link 4 guys. Now here the link 3, the center of link 3 is not lying on the body. Okay, it is not lying on the body. It is lying somewhere in the plane. It is lying somewhere in this plane of the rotation, not on the body. So by this, I can say that link 3 is undergoing general plane motion. Okay, the link 3 or the coupler link will be undergoing general plane motion, whereas the output link and the input link will be undergoing angular motion guys. Here we need to understand that. Okay, so I12 and 14 will be the permanent centers, whatever the configuration be. Okay, these will be the permanent centers, but whereas I13 will be roaming in this space. Where it may lie, that is decided on the basis of configuration. Okay, so here the link 3 is in general plane motion. So now guys, here what we can do is we can write the equation and then solve the angular velocities for link 3 and link 4. So in the examination, they will be giving us the angular velocity of the link 2. Okay, they will be giving us the angular velocity of the link 2, and it is very easy for us to write the equation. Now guys, here, as it is as it is evident to us that the link 2, sorry, I12 is the center of rotation for link 2 and I13 is the center of rotation for link 3. So now the velocity of link 2 will be perpendicular to the link 2, because velocity here we will be expressing this as the cross product. Velocity will be cross product of, that is, angular velocity and displacement. Angular velocity and displacement, omega cross r bar. So from here it is evident that velocity vector is perpendicular to r. Okay, perpendicular to r bar. And it will be decided in the direction of omega. We will be acting in the direction of omega. Okay, so here the velocity vector, let us say that it is undergoing rotation in the clockwise sense. So the velocity vector will be perpendicular to the link. So it will be like this, guys. Okay, this will be like this. Now if you notice, this point 23, I23 is having some velocity. Okay, point that is I23 is having some velocity. We call this as relative I center also. Okay, so this is having some velocity. Now we can apply the velocity theorem for this. Okay, so how to write that? It is very easy. Okay, so if I'm interested in calculating the velocities of omega 2 by omega 3, so I need to measure the distances from the center of rotation. Okay, center of rotation, not from the relative I center, from the center of rotation. What is the center of rotation for link number 2? It is known, that is I12, and center of rotation for link number 3 is in plane of rotation. So that is I23. So from that, from the centers of rotation, we need to measure the distances, radial distances towards the relative I center. Okay, so here we can write omega 2 by omega 3 is equal to, here I have to write I13. Okay, here if it is 3, this should be I13. And where is the velocity defined? At which I center it is defined? It is defined at I23. So I13, I23 is by, for omega 2, we will be writing this as I12, I23. This way we can write. Now guys, let us take one more example to write this logic. Let us say that we are interested, this is a 4-bar mechanism given to us, and let us say if we are dealing with some 8 or 9 linkages. Okay, so for link 2 and link 9, if I want to calculate or write the expression, then how to write it? Very easy, guys. First write it as omega 2 divided by omega 9. Omega 2 divided by omega 9 is equal to, this will be the center of rotation. First is that I have to write the center of rotation. Okay, center of rotation for link 2 will be I12. Why? Because link, why I am using here 1 in the subscript means 1 is the fixed link. So I have to define the center of rotation with respect to the fixed link. Please understand that. So I12, okay, and here on the top I have to write it as I19. I19 it has to be. Okay. And now these 2 and 9, they will be having some velocity. There will be a point where these two will be intersecting, and then at that point we will be marking the relative I center, that is I29. This will be I29, and on this side also we will be writing I29. Very easy for us to write this logic, guys. Okay, please do remember this. If you are thorough with this logic, then it becomes very easier for us to solve. Okay. Similarly, guys, we can make use of this for writing the angular velocities for link 3 and 4 also. Omega 3 by omega 4. For this also we can write. But first is that we need to mark up the centers of rotation. Okay. For 3, it will be I13. And for 4, it will be I14. I14 we have to write. If omega 4 is in the denominator, I14 should be on the other side, it should be in the numerator. And the relative I center of these two links, that is I34. I34, and this is also I34. Okay, this is how we can write. Similarly, you can also write the logic for omega 2 and omega 4 also, guys. Okay, but make sure that it has to be measured always from the center of rotation. Okay, center of rotation about which the link is going to move. Okay, so now guys, here we have understood that link 3 is undergoing general plane motion. So link 3 will be having some part of translation and some part of rotation will be there. Any link which is in translation, it will have its I center or center of rotation at the infinite distance. Okay, at the infinite distance somewhere in the space, if it is translation. But if it is rotation, it will be lying on the body itself. But now, this I13, we are noticing that it is at the finite distance, okay, but not on the body, which means that some part there will be some translation present and there will be also some rotation present, okay, when the I center is not on the link itself, on the boundary of the link, okay. So then there will be translation and rotation. So that is why we say that link 3 is in general plane motion. Okay, so here this is the very important concept, and then at least you will be expecting a question repeatedly being asked from this I center method. Okay, and this will give you the answers very quickly. Okay. Now let us take this problem, guys. Here, consider a 4-bar mechanism shown in figure. At a given position, the output rocker is to be driven in clockwise sense. Output rocker. Rocker, here it is given, that has to be driven in clockwise sense. Okay, at 2 radians per second. So omega CD is given to us. That is velocity of output link is given to us. Omega CD or omega 4, this is equal to 2 radians per second. Okay, 2 radians per second. Now, determine the velocity required, determine the required velocity of input crank AB. Velocity of the crank AB, what is omega AB or omega 2, that we have to calculate. Okay, the lengths of AB, BC, CD and DC are given as 20 centimeters, 50 centimeters, 40 centimeters and 50 centimeters. Okay. Now guys, here we can understand the way how the configuration is given. It becomes the angles, whatever the angles relating to this, describing the configuration of the mechanism, should be computed very fastly. The configuration will be given in such a way, guys. Okay. So now if we notice, this is 20 centimeters and AD, the length of the link AD is, that is AD is, DC it is given. DC is given, this is 20, 50 and this is 20 and this is 20, this is 50 centimeters. Length of AD it is, that is 50 centimeters. Right, so now we can calculate the angles also if we required, but otherwise not needed when we are doing the velocity analysis. Okay, so let us mark the I centers here. This will be link 1, this will be link 1, this will be link 2, this will be link 3 and this will be link 4. Okay. Now here, this will be I center I12, this will be I12, this will be I23, this will be I34 and this will be I14. These are the I centers, guys. Okay. the remaining two icenters we have to locate with the help of Kennedy's theorem. So what did we notice here? So here in this case, that is 1, 3 should be collinear with 1, 2 and 2, 3. 1, 3 should be collinear with 1, 2 and 2, 3. So 1, 2 and 2, 3, where is the line? 1, 2 and 2, 3 I need to plot. Okay. So 1, 2 and 2, 3, this is the line, guys. This is the line passing through 1, 2 and 2, 3. Similarly, guys, we know that 1, 3 is collinear with 1, 4 and 3, 4. 1, 3 is collinear with 1, 4 and 3, 4. 1, 4 and 3, 4, this is the line, guys. So here we can notice that I14 and I13 are coincident. I14 and I13 are coincident. So it is not difficult for us to measure the lengths of 1, 2 and 2, 3, 2, 3 and 3, 4, guys. So please understand that. Okay. Next is, similarly, if I want to locate I24, even if I am not locating I24, with this data also I can calculate the angular velocities of all the links, okay, remaining links. Right. So here the velocity of 4 is given to us, that is omega 4 is equal to 2 radians per second is given. So now we can write here omega 4 omega 4 by omega 3, omega 4, yeah, I think we have missed the, let me just mark the icenters once again, guys. This will be 1, this will be 1, this will be 2, this will be 3, and this will be 4. This will be I12, 2, 3, this will be 3, 4, and this will be I14, right? And the eye center, here we have marked 1, 3, somewhere here it was expected to lie. It will be coincident with I14. This will be I13, guys. This will be I13. Right. Now here we can make use of this formula, that is 1 for omega 4 by omega 3 is equal to the, first we need to write the center of rotations of 3 and 4. That is I13 should be coming in the numerator, because on the left hand side omega 3 is in the denominator, and this should be I14 should be written here, okay, and the relative icenters of 3 and 4, that is I34 and I34 here it shows. Okay. Now here omega 4 is given as 2 radians per second and omega 3 is not known to us. Omega 3 is not known to us. Okay. 1, 3 and 3, 4. 1, 3 and 3, 4 is 40 centimeters. 1, 3 and 3, 4 is 40 centimeters. And 1, 4 and 3, 4 is also still 40 centimeters. So from here we can conclude that omega 3 is 2 radians per second. Omega 3 is 2 radians per second. Similarly, guys, we can apply the velocity theorem and calculate the velocity of link number 2. Okay. So let us do that. Omega 3 by omega 2 is equal to I12, I23 divided by I13, I23. Okay. So omega 3 is known to us, that is 2. Omega 2 is to be calculated. 1, 2 and 2, 3, what is the distance? 1, 2 and 2, 3 is 20 centimeters. This is 20 centimeters. 1, 3 and 2, 3 is 30 centimeters. Okay. This is 30 centimeters. So we can write here omega 2 equal to, omega 2 will be, that is omega 2 will be equal to, this is 30 by 20 by 30 is my 1 by 1.5, so into 2 is 2 into 1.5, which is equal to 3 radians per second will be the velocity of the input link. Okay, will be the velocity of the input link. Option A will be our answer, guys. Option A will be our answer. Now, guys, most of our questions, they are asking only the velocity analysis. About 2 to 3 times, there was a question on the acceleration analysis. Okay, and that too for the simple configuration only. Okay, so let us do the acceleration analysis, or let us try to do the formulation for acceleration analysis for this given mechanism. Okay. This is 20 centimeters, guys, which is known to us. This is 50, this is 40, and this is 50. Okay. Now, guys, here, while doing the acceleration analysis, we can say that we will assume that link 2, or the input link, or let us say we are starting with the output link. The output link is rotating with constant angular velocity. We will assume that. Okay, we'll keep omega 4, that is 2 radians per second, that is constant angular velocity. Okay, so here let me just write here omega 4, that is equal to 2 radians per second. Okay, and here it is constant, guys, constant velocity, which means that alpha 4, or d omega 4 by dt is equal to 0. So alpha of output link is equal to 0. Alpha of the output link is equal to 0, guys. Now this is the point A. Let me just write here. This is point B. This is point C, and this is point D. So for carrying velocity analysis, eye-center method is the best answer. But if we are calculating, or if we want to do the acceleration analysis, then we have to go by vector method only, guys. Okay. Now here in the vector acceleration, we will be having 2 components. So acceleration vector will be having 2 components. One is the radial. One is the radial component of acceleration, and one is the tangential component of acceleration. There will be 2 components, guys. Any link which is undergoing angular motion, it may undergo angular motion with constant angular velocity or with constant acceleration, guys. Depends. So here we are assuming that link number 4 is undergoing angular motion with constant angular velocity. So now, guys, it is evident that alpha 4 is 0, then the tangential component of acceleration for link CD is 0, guys. So let me just write here acceleration of C with reference to D. This is equal to radial acceleration A radial of C with respect to D. Okay. Next is A tangential of C with respect to D. With respect to D. Okay. This is how it is written. Now, guys, D is the reference point and C is the moving point. So always do remember here in the subscript we write the second one is the reference point and the first E is representing the moving point. So now since alpha is 0, here we write this as CD into omega CD square, okay, and the vector is, or the radial acceleration will be pointed from the moving point towards the reference point. This will be the direction of radial acceleration. This will be the direction of radial acceleration. It is pointed from moving point towards the reference point. So this is in negative y-axis. So we will write this as minus j cap. We will be writing this as minus j cap. Similarly, guys, we can write the tangential acceleration as CD into alpha CD. So alpha or link CD or link 4 is undergoing angular motion with constant velocity. So this term will be cancelled out. This will be 0, guys. Okay. So CD is given as 40 centimeters and omega CD is also known to us, guys. Omega CD we have calculated that as, that is link number 4, omega for 4 is 2 radians per second. So this is 40 into 2 square j cap minus j cap. So this will be 2 square means it would be 4 and this is 4 into 140 minus 160 centimeter per second square minus 160 j cap it should be, guys. It should be j cap minus 160 j cap centimeter per second square. This will be the acceleration of point C. Okay. Next is, guys, we need to consider the acceleration of point B, okay, with reference to C. Let us write that. Acceleration of B with respect to C is equal to, this will be acceleration or radial acceleration of B with reference to C plus tangential acceleration of B with reference to C, guys. So here radial can be calculated very easily. Okay, we will be writing this as BC into omega BC square, and what will be the vector? It will be, here we are keeping the C as the reference point and B as the moving point, guys. Here we are keeping the C as the reference point and B as the moving point. So the acceleration will be directed from B towards C. It will be like this. It will be like this. What will be this angle, guys? Sine inverse of 40 by 50, that is 0.8. 0.8 means this would be 53.13. This will be 53.13, will be the angle, right? So it is pointing in the first quadrant. So we can write here BC into omega BC square, I cos 53.13 plus J sine 53.13. This will be the acceleration of BC, guys. Okay. So omega BC is given to us. You can substitute that. We have calculated omega BC as that is velocity of link number 3, which is 2 radians per second. Okay. So what we can do here is BC is 50 centimeters, 50 into 2 square, which is equal to 400. 50 into 2 square, that is equal to 200, guys. It is 200, not 400. 200. And this is cos 53.13. Cos 53.13 is 0.6. 0.6 times of I. And this is 0.8 times of J. Okay. This will be the vector corresponding to radial acceleration. Similarly, I need to write the vector for tangential acceleration. This will be written as BC into alpha BC. BC into alpha BC. And what would be the direction of tangential acceleration is not known to me. Now in that case, I have to assume, guys. I have to assume. But I know one thing, that is acceleration will be perpendicular to the link. The tangential acceleration will be perpendicular to the link. Okay. So I will assume that the link is undergoing, or alpha of the link is in the second quadrant. This is my assumption. My assumption can be false also. So if my assumption is false, then it will be reflected by a negative sign, guys. Okay. So now guys, here if it is, this is making an angle of 53. The line perpendicular to, with the line perpendicular to BC is going to make an angle of 90 minus 53.13, which is 36.86. Okay, 36.86. So this vector is pointing in the second quadrant. Let us write that. So I can write this as minus I cos 36.86 plus j sine 36.86. Okay, j sine 36.86 I can write like this. BC is 50, guys. Alpha BC is not known to me. So I can write this as 50 into alpha BC and minus I cos 36 is minus 0.8 I plus 0.6 j it would be. This is the acceleration expression for link BC, guys. Okay. Now guys, we have to write the expression for acceleration for link number 4, guys. For link 4 we are required to write. Okay. Let us write for the link number 4. So link 4 is link 2, sorry, actually. Link 2, it is link AB. For that we can write it as acceleration of B with respect to A is equal to radial acceleration of B with respect to A plus tangential acceleration of B with respect to A. Two components it will be. Radial will be pointed from B, that is moving point, towards A, that is the reference point. So from moving point towards reference point means it is pointing in the left hand direction. That means it is in minus I cap direction. Okay, that is in minus I cap direction. So we can write this as AB into omega AB square minus I cap, okay, plus AB into alpha AB, alpha of this, alpha in the case of link 2 will be in vertical direction, guys, will be in vertical direction. I will assume that it is acting in the positive y direction. I will say that it is in positive y direction. Okay, so let me just write that. That is positive j cap. This is written. AB is given as 20 centimeters and omega is known to us, that is 3 radians per second. So this is 20 into 3 square, that is 180. 180 minus I cap, okay, and AB is 20. Alpha AB is not known, j cap. Now guys, I have written the expressions of acceleration for the output link, for the coupler link and for the input link. Input link is AB. Now I need to relate all these vectors. Okay. So for that I have to write. So acceleration of B is equal to acceleration of C plus acceleration of B with reference to C. So here this will be the absolute acceleration of B. Absolute acceleration means acceleration of B with reference to the fixed point which is A. Okay, this is the vector summation. Next is acceleration of C or absolute acceleration of C, and the C point is moving with reference to fixed point, that is point D. That is point D. Okay. So acceleration of C with reference to D it has to be, plus this will be acceleration of B with reference to C. Right? So here we are required to add up the radial and tangential of AB, radial and tangential of CD, and radial and tangential of BC also. So if for AB, if we write for AB, it is minus 180 plus 20 times of alpha AB, minus 180 plus 20 times of alpha AB. And for CD, guys, we can write it as minus 160 J cap, minus 160 J cap, and adjacent to alpha AB, I need to write positive J cap, guys. This is, I have assumed the direction of alpha. Next is acceleration of BC, guys. We have calculated that as 200 into 0.6 is 120 I cap. 120 I cap. Next is 200 into 0.8 is 160 J cap plus or minus, I guess it is, minus it is 115 to 0.8 is 140. 115 to 0.8 is 50 into 0.8 is 40. So this will be 40 alpha BC, 40 alpha BC I cap plus next is 50 into 0.6, that is 30, guys. 30 alpha BC J cap. So now here you can equate the coefficients of I and J, get the values of alpha AB and alpha BC. So guys, here my intention is to make you understand, even for this simple configuration, the acceleration analysis is taking the time. So I just want you to practice so that you can be able to develop these equations very easily in the short time. Okay. So the question may not be given like this, but again, once again, a special configuration will be given to us wherein the alpha of the output link and alpha of the input link will be 0, and then you are required to calculate only the parameters relating to the coupler link. Something, this kind of a question can be given, guys. Okay. Though it is very simple in the velocity analysis, but we have seen in the acceleration analysis, it has taken slightly more time. Okay. So please practice this vector method so that you can draw, once you are thorough with the vector method, the relative velocity method or the graphical method becomes very much easier when you are solving. So first, I would advise you to start with eye-center method, then go for vector method. If you want to learn this relative velocity method, if you have a grip over vector method, then this becomes easier. Okay.
My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the